Hello, my name is Emily Sangmeister. I'm a graduate student studying graphic information technology at Arizona State University. This is a technical presentation about color proofing in the digital realm for GIT 573 color metrology. The purpose of this presentation is to discuss the basics of remote digital color proofing, which is currently the fastest, cheapest way for proofing prints for client approval before the final printed product. It will cover a brief history of print proofing, as well as the importance of color management and proper device calibration in order to ensure the highest quality reproduction of a design. Color proofing is essentially a test print to gauge accurate color reproduction before a print job. It has been around nearly as long as printing itself. Proofs were originally hard copies made with a printing press and needed to be viewed under very specific lighting conditions by the client for approval. Around the 1970s, laminated photographic systems were implemented, which reduced the time and cost to create a proof. By the 1990s, the standard proof type was the large format inkjet proof, which was still in a hard copy format but provided the most consistent color quality available at the time. The advancement of computer technology allowed proofing to evolve into a digital format. Soft proofs could be created and sent to the client via a PDF file. JPEGs were not used because their compression could cause the file to lose information as it was reproduced. Inkjet proofs in their physical form were still used, as well as high-end colored digital proofs, also known as contract proofs. These proofs, upon client approval, are considered to be a binding agreement between the designer, client, and printer for the output of the completed project. Remote digital proofing gained popularity with the increasing accessibility of high-speed internet access. This made the proofing process more efficient as files no longer needed to be physically sent to the client. A crucial component of an effective digital proof is color management. A color profile needs to be embedded in the metadata of the file to guarantee its output will be viewable as intended. Similarities and differences in colors can be measured by using the Pythagorean theorem to find the distance between two colors, which will then effectively calculate how accurate the reproduction is to the original. Beyond this, color management includes quality metrics, some of which can be seen with the human eye, such as color, lightness, contrast, sharpness, any artifacts present in the image, and its physical medium, for instance, the type of paper on which it is to be printed. In addition to these standards and specifications, color proofing also relies heavily on proper monitor calibration for each machine on which the proof is to be viewed. Monitor calibration can be done with software or professional hardware, and it ensures that the viewing conditions are as intended before the final image can be approved. Improperly calibrated machinery can delay the proofing and printing process and cost more time and effort, so it is incredibly important to have any proofing machines regularly calibrated to guarantee the highest quality viewing conditions. In conclusion, color management and monitor calibration are integral elements to maximize the effectiveness of remote digital color proofing. The understanding and utilization of this technology can save time and money, as well as improve the workflow of the designer, client, and printer. A lack of attention to detail during this process can cause some issues, but if a line of communication stays open between everyone involved in the creation process, many of these can be avoided, resulting in a high-quality product at a much lower price.